Hey everyone, as promised, I wanted to go over example 4 and example 5 from today's lesson that we did not get a chance to finish up during class time. It's coming from lesson 1.2 or 1-2. If you would, pull your textbooks out because in there you're going to see the problem that I'm talking about. In class, I have them up on the TV and I don't have access to that where I'm videotaping right now. So pull your books out. I'd like you to turn to page 13. If you need to pause the video while you're doing that, please feel free to go ahead and do that. And then come back on as soon as you have the problem in front of you. Okay, so now you should have your books with you, and the problem says this, and I'm reading it from my computer, so I'm going to step away a minute, but I'll be talking loud. Okay, it says that 4 friends use an online coupon to get discounts on concert tickets. They spent $312 for the 4 tickets. What was the price of one ticket without the discount? Okay, so we're trying to figure out basically what's the original price of the ticket. All as we know is there were 4 tickets purchased. I don't know what the original price was. I do know according to the chart. And if you remember in class today, I didn't have that information on my PowerPoint screen because it's another part of the problem that I did not actually place onto my PowerPoint. So I'm sorry about that. So let's go ahead and talk about that now. So you'll notice on your page, you can see this chart there. There's a discount of $15 for one ticket. So in order to find the total discount, you would take your 4 tickets that you purchased and multiply that by 15. So you know you're saving $60 overall from your price. And then of course the total order was $312. And that $312 was including that discount. Okay, so what is it that we're trying to find? We want to write an equation, first of all, to represent the problem situation, and then we are going to solve it. So from here, hopefully you can see my board okay. Okay, so from here, think about this. I have 4 tickets that I'm purchasing at discount. How do I know what the discount is? Well, in this part of my equation, I want to make a representation to show the discounted amount. So I'm going to call this original price, we're going to just call it the variable P. Okay, that's what we're going to refer to as the original price. So think about that. Now in here, I need to represent the cost of one ticket from starting at the original price and taking off the discount. So think about this. My original price is P. My discount is $15. That is the discount off of one ticket. But I need to multiply that by 4. So the price of one ticket is this right here. How many of those tickets did I buy? I bought 4. So it's 4 times, and inside the parentheses, we're going to place P minus 15. Now you might ask me, Mrs. Quigley, why is that inside the parentheses? Why can't I just write 4P minus 15? Well, let's look what this actually means. Let me put this in a dollar format here. What this means is I'm spending the original price on 4 tickets, and then I'm going to subtract $15 off that total. But that's not true, right? Each person, all 4 people are getting $15 each. So really, if you think about it, they're going to be getting $60 taken off of their price. So that's why we have to represent the discount inside these parentheses like this. And how much is that supposed to equal? Our total price, which is $312. Okay, looking for my walkie-talkie because I just heard it getting ready to go off. Okay, so here's what we're working with. This is the equation. Excuse me one second, I want to turn that off. Okay. All right, because you guys know how much that walkie-talkie can distract me, so I wanted to go ahead and turn it off. All right, so here we go. So here's the equation we're working with. Now we're going to use the distributive property here because remember we talked about this earlier in class today. If you have a variable inside your parentheses, the only way to free those up is to do the distributive property where I'm going to take the number on the outside and multiply it with all the numbers on the inside of my equation. So we do 4 times P, which is 4P, minus and then I take the 4 and multiply it with 15, and I'm going to get 60, a whole number 60. Here we go. Okay, and all of that is to equal $312. It's a whole number, so now I can drop off the dollar sign and the cents over here because there are 0 cents to this. Okay, now we need to undo this. And remember, we undo in reverse order according to PEMDAS. If you think about PEMDAS, we were working through this today, we look and see what we have. I have multiplication, which would be done first. I'll write that over here. I have subtraction, which would be second. Okay, so in PEMDAS, to solve a problem, we work down from the parentheses all the way down to the bottom. But to undo, we do it in reverse order. So the first thing I'm going to do is I'm going to undo the subtraction with addition, and then I will come back up here to multiplication, and that will be the second thing I do, and I do the opposite. Remember, I use the inverse operation of multiplication, which will be division. So let's do the first order of operation, reverse, in reverse order. We're going to undo, because remember, we're trying to isolate the variable p. So we add 60 to both sides. That will zero this one out. I will end up with 372, and I have 4p over here. Okay, now I'm going to divide onto this part right here. So I'm going to divide both sides by 4, because 4 over 4 would give me 1, or 1p, which is just p. And we divide this side by 4, and I end up with p, which is the original price, is equal to $93. So the solution to that problem then is $93. That is the cost of one ticket at original price. Now remember, they each got $15 off that ticket. But the question was, how much is the original price of the ticket? Okay, so that's how you do example 4. Now you can pause the video and try the Try It problem online. It is posted there in Google Classroom, and you can find it. It's 1-2, and you're going to find the Try It example 4. Okay, so go ahead and pause the video and work through that, and then you can come back, and I'm going to show you example 5. Okay, I'm going to turn my board around here. So I have a clean surface to work this out. I'm in a cramped little space here, so I'm doing the best I can here with a tiny little board, but I am grateful to have it, so I will not complain. Okay, example 5, and you're going to look in your books now. On the next page, I believe, you're going to find example 5, and that is going to be on page 14. Okay, so you're going to see something here. Let me read this to you. It says, LaTanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed. She expects to wait 30 minutes for the repair. Then she will ride her bike home. Can she be home in 1 hour? So the first thing I want to propose to you, and there's a little map there that you can see her route from her house to the bike shop and back, okay? So first thing I want to point out is there's always a relationship, and in the rest of your high school math career, you're going to need to remember this. When you're thinking about distance, distance is always the rate of speed times time. And by the way, guys, this is example 5 in lesson 1-2. Okay, we need to keep this in mind, and I would write this in your notes if I was you, just so you have it somewhere handy. Okay, and traditionally you would just put, look, there needs to be a little d. Little d equals, and I always use ST, speed times time. Now remember, with a variable, you can just write those up against each other. You don't have to put the time sign in between there. You can just put your variables together, and that means that you are multiplying. Okay, so this is how you would see this written. Now, let's kind of try to break down the problems for some better understanding. The first step is we want to try to write an equation that represents the situation that's going on here. So let's think about this. I'm going to think time because I hear a lot in the problems. I hear the time part of my distance. I hear all these parts. I hear distance. It shows me how far she walked. Rate of speed. Time is involved in there. But in the end, I hear time in there. So I'm going to actually write out in words the equation that we want to look to solve. So if I figured out the time she spent walking, and I add to that the time she spent at the bike shop, and to that I would add the time she spent biking. I think I'm going uphill here. That would give me the total time spent on this whole activity. Now, some of the information is clear to me and I see it. Now, how do I write a rate? And I want you to think about what a rate is. We dealt with those last year in our Saxon curriculum. If we have a rate is something like you walk 3 miles per hour. Okay, that's a rate. A rate is how fast you're traveling. It's not the time you took to travel, but how fast you are actually traveling. What is the rate of speed? So in this case, we are told in the problem that she was traveling to the bike shop, and it was 1.5 miles from her house. And it says she was traveling at 3 miles per hour. All right, so here's how you write the rate for that. She's going 1.5 miles, and the rate goes underneath at 3 miles per hour. Okay, time walking. The time she spent at the shop was a half hour, we are told. And then lastly, the time biking, we are told, is 1.5. Did they tell us it was 1.5 miles, or we know that because we know it was 1.5 miles from her house to the shop. So therefore it must be 1.5 miles to get back home. So 1.5 miles, but she's biking, so she's traveling a little bit faster. She's traveling 10 miles per hour on her bicycle. And our total time is what we don't know. So we're going to call that T, small letter T. Now, let's figure this out. If you have your calculator, you simply take 1.5 and you divide it by 3, and you're going to end up getting 0.5. And then we're going to add our time to this. And we notice here that we're talking about hours. Our rate is written as miles per hour. So we're going to change this half here to 0.5. I'm sorry, I meant to say we're dealing with decimals. So we're going to change the 1/2 to 0.5, and that's very messy. All right. And then if you do 1.5 divided by 10, you're going to get 0.15 equals the time that she traveled. Now, if you add all of these up, you're going to get 1.15 for your time. Now, I have to ask you, the question is, does it take her, can she get there in less than an hour? Well, no. And are we supposed to also say the time that it did take? Well, we can figure that out. 1.15. Okay, so what is 1.15? Well, we know that this represents the 1 hour. It's not 15 minutes, okay, but it is over an hour. So the answer to this would be no, she cannot get there in less than an hour. But let's go ahead and convert this into minutes. What is 0.15? Well, let's think about this. Remember, 0.15 is equal to 15 hundredths. That is 15%, right? So that's 15% of a whole hour. And a whole hour is how many minutes? Because that's what we're looking for. We want to convert this into how many minutes that is. So 15% of 60 minutes. That'll tell us how many minutes over an hour her activities took her. And if you multiply then 0.15 times 60, you're going to end up with 9 minutes. So therefore, it took her 1 hour, I'm going to squeeze it in right here because my board's so small, 1 hour and 9 minutes to leave her house, walk to the bike shop, spend a half an hour at the bike shop, and then ride her back home. Took her 1 hour and 9 minutes. The question was, could she do all this stuff in less than an hour? So no, she couldn't, because it took her 1 hour and 9 minutes. So that's how you would figure that problem out. Now I would like for you to go ahead and pull up the try it problem, which is going to be for example 5. Try it. Example 5, you'll have to find that in your Google Classroom as well. And then there are 10 problems that are assigned for homework that will be due when you come back to class on Thursday. If you have any questions at all, please don't hesitate to reach out to me and ask me for help. I'll be happy to do that, and I will plan to see you all on Thursday. Have a great evening, everyone. Thanks for watching.